Hello, and welcome back to an overview of AbLead, the Antibody Analysis and Engineering Suite from Ketchum Biotherapeutics Consulting. In this video, I'm going to show you the Humanness tool. Humanness tool is used in the main grid to generate a score for the overall rank order score. I'll scroll all the way to the right to show that to you again. And it calculates a score for VL, VH, and a weighted score using these two for the entire FB. This method is based on the OASIS method in BioPhi, and if you look at the help documentation by clicking on the question mark, you can get a link to that paper. That method uses overlapping 9-mer peptides and compares them against curated sequences from the observed antibody space. Looks for peptides that exist in human response. So in this case, this entry, example 9, has a pretty low Humanness score, so it has some peptides that don't appear in human response. So let's take a look at this entry. I'll come to analysis to the Humanness tool. It loads the tool, analyzes the Humanness, evaluating all of the peptides. You can see the scores again, the VL score and its germline, the VH score and its germline, and then the weighted FB score. And it shows an overview of, or an overlay to the top 5 germlines for the query. So you can evaluate the query sequence against germline positions. You can look across here and see that indeed here's a set of 9-mer peptide overlays that do not appear to be human. In the colored regions are the depiction of the default system CDR boundaries, in this case, north boundaries. If I mouse over, as you were seeing, you can see where the peptide, the 9-mer peptide lies, and how many mutations it would take for each peptide to reach human. If I click on one of these residues, it will scroll us in the grids down below for the light chain and the heavy chain to the position that was selected. In this case, I clicked on that methionine. It shows up right here in the entry. I already have a couple of mutations that are made, but that's indicated by these dots on these positions. And the information that's given in this grid now is not only can you look to see that AA is the germline across the top 5 germlines, but that for these positions, they have 0% humanness. AbLang, the OPIG large language model that looks at the context of the entire sequence for what residue should be in that position, says it's a very large violation from E or M, and both of them should be A. And if we look at positional frequency analysis, it says that E is 0% at this position, IMGT 96, and M is 0% at position 97, but that both of them have very, very high scoring as being an alanine. What this means in positional frequency analysis is an overview of millions of sequences from human response and showing the frequency of an amino acid at that structure-based position. In this case, the highest scoring positional frequency analysis for both positions is alanine. Now, within the tool, I can click and enter a mutation. I've already done it here. You could give it a group. I could call this immunogenicity or humanness. The hope is that by removing these high scoring violations that you reduce the potential for immunogenicity or anti-drug antibody in this antibody. Save that mutation. Do the same thing for this alanine. Call it immunogenicity. Save that mutation. You don't have to give the engineering groups a group, but it's kind of nice when you're doing engineering to know where your thought process was, where those came from. So I'll just focus on these two. There are others that I would mutate, and actually I would go through and even look at CDR positions along with a structure analysis to be able to evaluate these for true optimization. You can see down at the bottom, there's a legend that is showing the positions that are outliers and how they're scored in terms of coloring. You can also export this to Excel. It doesn't match what you see in the web. It instead gives you a view that allows you to populate this into an ELN or put it into a report. You can see the germline background, the scores of the VL, VH, and FV. And then for the light chain and the heavy chain, the um, the region, the residue, the OAS percentage for that position, the AbLead difference, and the positional frequency analysis information. So you could go through and use this offline or to communicate to others as to how mutations should or were made. So I'll just come back to the tool. I mentioned that those were entered into engineering, so we'll come in here into engineering. And if I scroll down here, you can look for those EM positions. They're right here, and you can see them right here. And if I scroll over a little bit, you see these say immunogenicity. Here's one that I had entered. Let's just pretend this was fixing an isomerization site. So as you've come through and done some engineering, I'll select these. I won't select this isomerization site, and I'll generate those as combinations. Oh, looks like I had already generated some combinations, so let me delete those, regenerate, and here are those all possible combinations of alanine at these two positions. So I'll select these, and let's go ahead and build these. I can export this as a grid for a notebook. I can export this as a grid for a notebook. I could just build the FASTA sequences if all I wanted to do was have these made. But usually you'll want to build these as selected entries so that you can see the totality of the impact across all measured values in the main grid. So this is calculating. It will just take a moment to calculate all three. And it return me to the tool. It returns me to the tool in case I wanted to do more engineering, but I'll just hop over to the grid and I'll sort these by name. And there are the 4 entries, the parental and the 3 engineered versions. Wouldn't worry about the distance being red here. It just means that I've only made a couple of mutations from the parent, and we know that, so no big deal. We can look at the impact on the stability violations, and actually you see that by improving the humanness, you've also improved the stability by the AbLead measure, so that's a good sign. If I were engineering these, I would try to fix this missing salt bridge as well. These have no PDB files uploaded for them yet, so no surface properties have been calculated. Now just scroll along over to the humanness score, and you can see that the humanness scores have been improved tremendously. And if I look at a mutation grid, the one that has both alanines is engineering 1. And so if I come back here and look at engineering 1, it has the best humanness score for the FV of all 3, of course, because we've engineered both of those sites. We could improve this even more if we focused on more of the sites, but this was just a demonstration of how the humanness tool can be useful for evaluating an antibody for potential immunogenicity and utilizing the other tools in the suite to help to engineer these molecules. It is one of the benefits of AbLead that multiple tools all come together that interact with each other to help with engineering. I hope you've enjoyed this. Look forward to hearing from you if you'd like a hands-on demonstration.